Our next speaker, we are moving to Dr. Rossawan. She's representing Scarcity Bank, and what triggered my interest, she has a very interesting set of tools and very progressive from the point of how to use the data and how to actually access the data by filling the gap through blockchain technologies. So I wonder if we can introduce Dr. Rossawan. Dr. Rossawan, she's Associate Director, Head of Scarcity International Advisory of GPS MNC Banking Bank of Ayutthaya in Thailand. She's part of the global advisory team, which gives advices in bound and outbound international investments and import-export foreign countries. So her expertise includes sustainable development and human capability in Japan and Thailand. So please welcome with me Dr. Rossawan, and please make her slides available.
Good morning, ladies and gentlemen. Thank you, Ida and Kurt, for inviting me to speak in this panel. I'm representing Scarcity Bank today to propose some innovative solutions which could unblock water scarcity through blockchain from a banking perspective. But talking about blockchain technology, I promise I won't use too many buzzwords, and I'll try my best to talk like a human. Since I come from a bank and the other distinguished speakers have already discussed about water, I am going to talk more about the financing point of view through data sharing through the blockchain technology. Please take a look at the chart in the next slide. This slide. This is a very interesting chart as it shows the costs we need to spend in order to have clean and sufficient supply of water by 2030. This is called water supply, sanitation, and hygiene, also known as the WASH program. Looking at the annual spending in 2015 in blue and compare it with the annual requirement to meet safely managed WASH by 2030 in orange, it is very clear that the status quo is not enough to achieve the goal and bridge the financial gap, which is due to increasing water demands. So as for financing, investors, before they invest, what do? They study data before they invest, right? So if there is enough data, it is easier for an investor to put money in. So it's fair to say that data leads to investment. And in order to reduce costs and attract more investment for urban water over the next 10 years, my opinion is data and smart technologies must be embraced so that investors can be more confident to invest, and so that the development can start, and so that interventions can be as effective as possible. And the focus is, of course, on urban, because attention is where the people are, and that is in the urban areas. So we would like to propose that the data and smart technologies, especially in the urban areas, should be embraced. This is the example of a successful case in Canada and Australia, where effective storing and management of data is conducted throughout an urban water cycle. In the case of Canada, an integration of open data with remote sensing, satellite imagery, Internet of Things, and AI could allow predictive modeling based on real-time water quality. Adding input data such as weather or nutrient flows, pollutants could help forecast water quality ahead of time in a river system, as well as help companies assess their water risk. Open data directly increases entrepreneurial activities and improves business services. And in Canada, blockchain is being trialed for data sharing, for water trading in water markets, for dam management, and for pollution control. And in the case of Australia, water markets are viewed as a key area of engagement by blockchain enthusiasts, because, as you know, Australia's clarity on blockchain regulations combined with the maturity of its water markets has fostered a high level of innovation As an example, an Australian company, which is a civic-focused blockchain company, created a way to improve transparency of water trading in the country's water markets. And their real-time updates of state water registries was enabled by smart contracts. But before we go to what smart contract is, I want to show you how blockchain might work for the water sector. Blockchain is like a decentralized record of information. The potential applications of blockchain for the water sector could help to achieve the goal of an accessible, open source, and open access to share water data between public and private sectors and relevant actors. The water information such as the leaked wastewater, the rainwater, or water data like the water demand and supply from the WEAP tool that Diane has already mentioned earlier, or the water data from the BUMP program. This kind of information is recorded by consensus using confirmation from several nodes, or for example, several computers. So you can imagine having several smart sensors in a water pipe, and those smart sensors monitor the flow of the water in the pipe. And then all these smart sensors record the same flow at a given time and record this data. And with the blockchain, once the agreement has been reached between all those devices about the flow, then the information is stored, and then it cannot be disputed or changed. And this is actually very transparent. And along with the consensus and the immutability of the information recorded, what makes blockchain unique is that it is not centralized in one place or in one database or in one ledger. Instead, many copies of the data are kept in different places on the network. So on the blockchain, if one piece of the information or the record is changed without consensus from the rightful owners, there are multiple other copies of the record out there to prove that the change was false or obsolete. So the idea of the information not being kept in one centralized place, we call it decentralization. And decentralizing water data on the blockchain could be a solution to water scarcity. So as a result, I propose two new shifts. The first one, we need to change the way we manage water today, and we have to shift from centralized solutions to decentralized solutions, transforming our perspective on from the linear use and dispose water approach to a more sustainable circular economy model. And secondly, we need to use innovative solutions for funding, because as you know, public utilities and governments are typically unable to meet development finance demands solely through public resources and have to attract new sources of financing all the time. And also another problem is unlocking private sector capital for development projects that aim to provide safe and affordable water and sanitation to the poor is quite challenging due to a lot of uncertainties in their return on investment. So this is where innovations are needed. And these financial obstacles can be translated into opportunities for banks, for example. We can have a new form of banking products, or we can even introduce crowdfunding schemes, which is another innovation scheme. So now we've talked about financing, we've talked about the importance of data, the blockchain technology, and decentralization. So how does all this fit into a blockchain to unblock water scarcity? I would like to introduce the three main levels of blockchain here. The first level is the storing of digital records in a controlled, secure, auditable, and immutable way, and not simply of transactions, but also of digital representations of physical assets. For example, utilities water quality data, rainwater amount, wastewater, etc. And then the second level is the exchange of digital assets. In this case, it's the water assets, where people can transfer ownership in real time. For example, in Australia, they have the water trading in the water markets, so they can transfer water assets in the case of water trading, or it can be as simple as paying for a water bill. And Water utilities face a lot of challenges at a local scale, and as you know, the centralized system is quite costly and it may take time and not as speedy as the decentralized system. So the third level is going to be about the smart contract. And the smart contract is like an execution of smart contracts, of the contracts that are written in codes, and it includes rules and conditions and expiry dates and other information that are put in the contract. And as soon as the conditions of the contracts are met, then the information gets automatically executed. Smart contracts allow businesses to reduce time spent on paperwork and enforcing contracts and interaction with third parties. It is easier for us banks as well to verify those information through smart contracts. And these programmed applications can be used for simple cases like escrow payments, which could be useful in insurance claims, in the water trading markets, or by pay-by-results financing. So this is just a simple diagram of how a smart contract works. And being mindful of time, for more information on the pay-by-results smart contract in the WASH program, you can feel free to read further in this material. But simply, it's just a payment for achieving specific outcomes. Pay-by-results smart contract could be designed for funds to be released once the data is verified by monitors or by evaluators, then the payment is made automatically. The money can be released automatically to the project implementators. And last but not least, my key message for this is that collaboration is needed in both supply and demand sides at both governmental and human levels. For the supply side, we need to ensure funding, and in order to attract funding at the governmental level, there should be political prioritization, there should be a functioning legal framework, and of course transparency in water cycle management. And at the human level, at the community level, or the demand side, we need to, especially in Thailand, we need to improve understanding of better sanitation, and we need to develop education and awareness for the people to understand and to put out the right psychology in their minds that water is not as abundant as before. So that is the message from me. Thank you very much for your time.
Thank you very much. We managed exactly with all the presentations to fit